Start ചെയ്യാം sir.
എത്ര പേര് ജോയിൻ ചെയ്തിട്ടുണ്ട്?
29.
29.
Total 29.
Okay, you can start.
Okay. Good morning to all. Today we have gathered online for the webinar on aerodynamics in cars. The resource person for today's webinar is Professor Shivkumar S., Head of the Department Mechanical, Ace College of Engineering, Trivandrum, Trivandrum. Welcome, sir. And I welcome all the participants to this online event. Without further ado, let's get started. Thank you all, and I turn it over to you, sir.
Good morning to all. I am Professor Shivkumar. On behalf of Ace College of Engineering, I welcome you all to this webinar, Aerodynamics in Cars. The schedule of this webinar is 45 minutes presentation, followed by open discussion for 15 minutes. First, I would like to give a brief introduction about the topic. All of us know automobile is a fast-growing industry. There is immense competition, and companies try to produce products with very high quality and in varieties. You take any company, Tata, Maruti, Toyota, they have produced different products to suit the taste and preference of customers. When we purchase a car, normally we will take into consideration many criteria. Some of the criteria are fuel economy, appearance, stability in high speeds, noise level, and many other factors in selecting a car. Shape of the cars contribute to appearance, fuel economy, and stability, especially in high speeds. Today, let us discuss the importance of aerodynamics in design of cars. The table of content is first an introduction about aerodynamics, then drag and lift, influence of different parameters in drag and lift coefficients, air dam and spoilers, aerodynamics of F1 cars, methods of studying aerodynamic forces, and conclusion. First, let us see what is aerodynamics. In simple words, we can define aerodynamics as study and analysis of different forces acting on a body moving in air. When a body moves in air, there will be different types of forces acting on it. A study of that is known as aerodynamics. It has got application in different areas of engineering. To highlight aerospace engineering, design of automobile, prediction of forces and moments in ships and sails, in design of bridges and buildings, considering wind loads. Of this, our discussion is the second one, design of automobiles. Now let us see what are the forces in aerodynamics. Lift, drag, weight, and thrust. Lift is the force acting normal to the direction of flow of air. If due to lift, if the body moves upwards, or if the direction of lift is upwards, we can say it is positive lift. And if the lifting force is downwards, we can say negative lift. And why there is a lift? It is mainly due to the pressure difference between the bottom and the top of the body. When the body moves in air, there will be forces acting at the bottom of the body, or there will be pressure, air pressure at the bottom of the body. Also, there will be pressure at the top also. Due to the difference in pressure, this lift is created. If the force acting on the bottom of the body, or the force due to pressure of air at the bottom of the body is more than the force due to pressure at the top of the body, the body will move upwards. There will be a upward force. When this difference in force is more than the weight of the body will move upwards. Because the weight will be always acting downwards. And lift is the force due to pressure difference at the bottom and top of the body. The force created due to the pressure difference, the lift, if it is more than the weight, the body will move upwards. If the lifting force is less than weight, it will remain in that position. Or if it is in air, it will go down. Now, the second one is drag. Drag is mainly due to the resistance offered by air for the movement of the body. When the body moves in air, there will be resistance offered. That is known as drag. The drag may be if you take a vehicle, when the vehicle is moving in air, there will be pressure acting in the frontal area. And in addition to that, there will be drag in the rear end also. Here, when the body moves, there will be pressure acting on the frontal area. That is one type of drag. The second one is, as it moves, it will replace the air in the volume of space it occupies. The air in the volume of space it occupies will be continuously changing. So it replaces the air in that area. So when it moves forward, the air in the side will be surrounding, that will be rushing towards the center. Because vacuum is created there. When the body replaces the air in that area, vacuum is created. Due to that vacuum, the air will be flowing towards the center. So some wake will be created. Some turbulence will be created. So we can say there will be a pull from the package. So drag is mainly due to two reasons. One is due to the pressure, air pressure on the frontal area, and the pull from the backside due to vacuum created in the rear end. Then weight, the weight of the body will be always acting downwards. Thrust. Thrust is the force we create to move the body in air, because there is drag. Drag is the resistance offered by air for the movement. So we have to overcome that drag. Then only the body can move. Also, the weight is to be moved through a distance. So we need force to overcome that drag. That is known as thrust. These are the 4 forces acting in aerodynamics. So if you take a car, many parameters or many factors are decided by the design of the car. I told you, one is fuel efficiency, then appearance of the car, stability of the car at high speeds, and noise level. These are the advantages of aerodynamics principles in design of cars. I have already given you some idea about drag force. Here, you see the expression F is equal to half CDA V square, where F is the aerodynamic drag force. That is the drag force created in the frontal area due to pressure of air acting in the frontal area. And C is the coefficient of drag. Coefficient of drag is a measure of drag force. And A is the frontal area. And D is the velocity of the object. So when a body with the frontal area A is moving with the velocity V in air, the drag force created will be half CDA V square. Here we can say the drag force created depends on coefficient of drag and the square of the velocity. So if the velocity is very high, normally the drag force created will be very high because it is directly, if C is coefficient of drag is also treated as a constant, because density of air, we can say in a level it will be constant almost. Then coefficient of drag also, it may be more or less constant. Then frontal area will be constant when a body is moving. So we can say that drag force is directly proportional to, or it depends very much on velocity of the object. Now, when a car is moving, what is the force required? What is the thrust required? That force has to overcome this drag force. So the minimum force, if the weight is not taken into consideration, the minimum force you require should be F. But we are moving a weight over a distance. So work is done on that. Friction will be there. But if the weight and friction, everything is not taken into consideration, we can say the force you require to move the body should be just sufficient to overcome the drag force. When a weightless body is moving, if the thrust it produces is more than drag force, it will move in the forward direction. I have told you drag coefficient. Drag coefficient is a measure of aerodynamic efficiency. And this drag coefficient varies with the shape of the body. Here, the drag coefficient for some of the shapes are given. For sphere, the drag coefficient is 0.47. Half sphere, 0.42. And streamlined body, it is very less. It is like a teardrop. For a streamlined body, it is 0.04. And streamlined half body, it is 0.07. These are the drag coefficients calculated by conducting tests on different shapes. And we have seen the drag force depends on coefficient of drag. So the thrust you require depends on shape of the body. Where if a car with tear shape, teardrop, that is a streamlined body, moves in the air, it may require only very less force to overcome the drag. Because the value of CD is very less, 0.04. Now, let us see when a flat plate moves normal to the air. When it moves, what will happen? It's moving in the forward direction. So pressure will be, air pressure will be acting against the body. It is kept normal. Okay, normal to the flow. So air pressure will be acting on one side. And as it moves through the air, it will be continuously replacing the air in the volume of space it occupies. So what will happen? Vacuum will be created in the rear end. When vacuum is created, what will happen? After crossing the body, the air particles will be rushing towards the center. So some sort of turbulence will be created. This is movement of a plate, flat plate, normal to the airflow. Now, you take a flat plate kept horizontally. It is kept in a direction same as the flow of air. It's kept horizontally. First figure you can see A. Here, boundary layer theory is applicable. That is, the air particles touching the surface of the plate will have zero velocity. If you take the air particles above that, you can see the velocity of air particles increasing up to a certain height. After certain height, the velocity will be almost the same. There will be a velocity gradient just above the plate. The question is, you may think, why this is important here? Here, when a car moves in air, first you start from the bottom. There is bumper line, frontal area, then above that hood, then windshield, then top of the car, rear window, trunk. So the air passes through different parts of the car. Here, from the bumper, frontal area, hood, windshield, top of the car, rear window, and trunk. And the sideways flow, it will be just flowing over the doors. Okay. And if you take the roof of the car, it is not exactly flat, but if you take very old cars for Fiat and all, it was almost flat. So this boundary theory, here it will be, the type of force will be wall shear only. The type of force will be wall shear only. Now, we already discussed when a flat plate is kept normal to the floor, what happens? Now, we'll come to aircraft wings. You see the shape, it is like a teardrop. Here, when air flows over the body, at the top of the body, the air particles have to move over a long distance. And at the bottom, the distance to be moved is less. So when air flows at the top of that body, top of the wings, it will be moving with a high velocity. When it moves with a high velocity, normally, according to Bernoulli's equation, Bernoulli's principle, the pressure will be less. And at the bottom, it moves with less velocity. Since the velocity is less, normally the pressure will be more. So at the bottom, the pressure is high, and at the top of the body or top of the wing, the pressure is less. So a lifting force will be created there. A lifting force is created due to the pressure difference at the top and bottom of the body. So a force will be acting due to the pressure difference, and that will try to lift the body. This is what is happening in aircraft. And if you take an aircraft flying in a particular level without changing the height, their lift and weight will be equal. Lift and weight will be equal. If the lift is more, then it will move upwards. If the lift is less, it will move downwards. When it moves in a particular level, particular height, the weight will be balanced by the lifting force. Now, if the thrust is more than the drag, there also drag is there. When the thrust is more than the drag, the aircraft will accelerate. If the thrust is less than the drag, it will decelerate. Now, here the explanation is given using Newton's third law of motion. Here, when air particles move over the wings, the speed increases at the top and speed is reduced at the bottom. Now, here, according to Newton's third law of motion, a lift occurs when a moving flow of air is turned by a solid object. After striking the surface, if the air particles take a turn downwards, then a force will be created in a direction opposite to that. That is the lifting force. Now, here the reaction of force on inclined plate. We have seen what will happen when a plate is kept normal to the direction of air, flow of air. We have seen what happens when a plate is kept parallel to the flow of air. Now, when it is kept at a particular angle, all of us know there will be two components. One is the upward force, that is the lift component, and the other one will be in a direction opposite to the movement of the vehicle. That is in the direction of air. That is the drag component. Now you see what happens to the upward force and the backward force when the angle of inclination is changed. Yes, this angle is also very important. You take bonnet. Bonnet is at a particular angle. There is a slight inclination. You take windshield. It is also in a particular angle. So the lifting and dragging forces are decided by all these parts. So reaction force on an inclined plane. Please see that as the angle decreases, the lift component increases and the drag component decreases. So we can say here, for small angle of inclination, the lifting force will be more when it is kept at an angle in the direction of flow, angle to the direction of flow. The angle is less, the lifting force will be more, and when the angle is more, the drag force will be more. Now, let us see what happens when the air flows over a streamlined body. We have seen teardrop and all. When the air particles moves over the body, if it is a streamlined body, there will not be any separation between air and the surface of the body. The air will flow over the body and it will move along the surface of the body till the rear end and it will come out. You take the first one, laminar flow around a good shape. The air particles moves along the surface of the body. Here, till the rear end, there is no separation at all. The air particles are not separated from the surface of the body. Now you take the second one. Here, the separation takes place in the frontal area itself. So there is a separating point. Air is diverted into some other direction. So what happens? There is a separation between the surface of the body and the air particles moving close to the surface. Due to that, what will happen? There will be some turbulence created. We can say wake is created there. Due to the wake, there will be a drag. If the intensity of that pressure drop is high, or if more wake are created, in that case, the drag force, the force pulling the body backwards will be more. Now you take the third one. The angle of inclination is more. The front side, it's almost like it is teardrop only. The shape is almost like teardrop only, but the angle of inclination is more. When the angle of inclination is more, normally there will be separation. When there is separation, there will be wake created and the drag will be more. You take the last one, shallower angle. The last one, you see the angle of inclination. The angle of inclination of the fourth one is lesser than the previous two. So what happens? It's a streamlined one, but at the end, there is a possibility for wake, but it happens only after the rear end. So the effect will be less. Air particles strike the body, it moves along the surface of the body, and it crosses the rear end. Now we can see the CD, coefficient of discharge, sorry, coefficient of drag of some of the cars in India. CD of Benz is Benz CLA is 0.22. I think that is the least one. BMW i8 CD is 0.26. Now you'll see what happens when a car moves in here. Here different arrow marks are shown. There are arrow marks in green color, yellow color, red color. And if you see the length of the arrows, green in the beginning, see the length of arrow is long compared to the length of arrows touching the car. Here, when the air approaches the car, first the density of air will be less. When it approaches the car, the density of air will start increasing because there is an obstruction. And when it is very near to the car, the frontal area, you see, it is red. The density is very high. And density is very high, so the pressure also will be very high. Because when it approaches the car, in the frontal area, the pressure goes on increasing. And when it touches the car, the pressure will be high. The air pressure increases when it approaches the car. Like that, what happens when it flows over the roof of the car? In certain cases, when it moves over the roof of the car, the air particle continue to move in that direction. So there will be detachment of air, flow detachment. Due to the flow detachment, the air particles will be rushing towards that part, towards the vacuum created. But the drag created is due to the vacuum created behind window and the trunk. As the air particles moves over the roof, it will continue to move in that direction. So there will be flow detachment. Due to flow detachment, vacuum will be created, and that creates the rear vacuum. And due to the rear vacuum, there will be drag. Now see, as the air particles move towards the frontal area, it is getting compressed, the density increases, the pressure also increases, and over the bonnet, when it flows, there is a possibility for lift also, because fresh air will be touching that bonnet part, and the density will be less normally because the obstruction is only at the bottom area. So when it moves over the bonnet or hood, there will be lift and drag. There will be a lifting force. Then when it moves over the windshield, you see the pressure variation. There is red. Red means the density is high. So there will be a down force. Then when it moves over the roof, normally the velocity will be high. So the pressure will be less. So there will be a lifting force. Like that, you see the backside. When the air particles continues to move, what happens behind window and above trunk? There will be vacuum created. So there will be a lifting force. Because air is flowing to the bottom also. To the bottom of the car also air is flowing. And the lift is the forces acting upwards. Okay. And the lift is created mainly due to the pressure difference between the bottom of the car and above the car. Now, in this, you can see the air particle approaching the vehicle. It is flowing above the car. It is flowing below the car. It is flowing through the side of the car. So the flow will be in different directions. And below the car, if the air pressure is more than pressure at the top, there is pressure at the top of the car, there is pressure at the bottom of the car. If the air pressure at the bottom is more than the pressure at the top of the car, then there will be a cross flow also. The cross flows is also shown. Upside arrows surrounding the car. Okay, so there will be different types of air will be flowing in different directions. So the forces will be in different directions. And when it reaches the rear end, when there is cross flow from the top, bottom, along the side, there is a possibility for vortex created. So on both sides, there is a possibility for vortex. When vortex cone is created, there is a possibility for negative pressure at the rear end of the car. Now, we have seen what is lift. For lift also, lifting force. But lifting force also, there is an expression. The lifting force equal to of coefficient of lift V square A. D is the density of air. Okay. V square is velocity of the vehicle. A is the effective area. So if the coefficient of CL is very high, that is coefficient of lift is very high, there is a possibility that the car can be lifted. What will happen if the car is lifted? The driver may lose his control. Is it not? This may happen at very high speeds. When the speed is very high, if there is considerable coefficient of lift, there is a possibility that the contact between the tire and the road may be okay. When there is no contact between tire and road, the driver may lose his control. Okay. You make it a point, if there is very low pressure on the top of the body, and the pressure, there is considerable pressure at the bottom of the body, bottom of the car, and if the car is moving with a very high velocity, then there is a possibility that the driver may lose his control at high velocities. And now, one thing we know, in case of coefficient of drag, by streamlining the body of the car, the separation points can be shifted beyond the rear end. So the drag can be reduced. And like that, this coefficient of lift can also be controlled by making small variations in the shape of the car. Because the coefficient of lift is decided by the shape of the car only. If there is provision for reducing the pressure of air at the bottom of the car, and to increase the pressure at the top of the car, then there will be a downforce. There will be a downforce. This downforce can be created because if at high speeds, if there is a lift created, and if the lift is more than the weight of the car, then the car may be lifted from the ground. The driver may lose the control. To avoid that, we can make small provisions in the car in order to keep the pressure below the car to a certain level. There are many parameters. We will see that one by one. Now, you see atmospheric air approaching, atmospheric pressure air is approaching. When it reaches very close to the car, the pressure increases and it may take different directions. That depends the shape of the front side. We'll see that separately. And if fast moving air is at the top, that will lead to reduction in pressure. So the pressure may reduce there. At the bottom, if there is a if the flow is controlled and if the flow is more than the pressure at the top, there will be a lift. So by varying different parts of the shape of the parts of the body, we can control the coefficient of discharge. We can vary the coefficient of discharge and coefficient of lift. Now, this shows the aerodynamic lift versus ground floor height. Ground floor height is here. It is shown the car, even at the top. H is the floor height, and B is the distance between the center of the wheels. And here, H by B is taken along x-axis and lift coefficient along y-axis. And you would have noticed if the gap between the car and the road is very less, then there is a possibility for positive lift. And if it is moderate, then you can see how the lift coefficient varies with H by B. So make it a point, lift coefficient varies with floor height. So the floor height can be varied and we can control the lift coefficient. This is what we have already discussed. Now, front and nose shape, the front side, the bumper area, here the front side, you can keep the nose tip, nose tip, either pointing downwards or pointing at the center or pointing upwards. The conditions will be different for different positions. Suppose if it is pointing downwards, what happens? Only very small quantity of air will be flowing through the bottom. And most of the air particles will be moving above the car. And there will be the diagonal flow will not be there. Even if it is there, it will be very small. Then, if the tip is at the center, there will be flow above and below the car. Okay. And if the tip is pointing upwards, what happens? More air is going to the bottom of the car. Only very less quantity flows above the car. In that case, what can happen? Just see, more quantity of air flowing to the bottom, very less air moving above the car. So the pressure at the bottom will be high. So air will be coming, there will be airflow from the bottom to the top. And now you can see there are airflow above the car, it is less. So pressure will be less at the top. Below the car, more quantity of air is there. Pressure will be slightly high. So the air will start moving from the bottom to the top. And that will lead to some vortices. Because there are flow in different directions. Some vortices will be created at the rear end. Now, there is a wind tunnel setup, experimental setup. This wind tunnel experimental setup is used to study the forces acting on a body. You can make a prototype of the vehicle. In this setup, you can keep that inside the wind tunnel. And in wind tunnel, there is provision for passing air at different speeds. So using that provision, you can vary the speed of air flowing through the wind tunnel. The body is already kept there. You can make prototypes in different shapes. You can make prototypes in different shapes. You can keep it inside the wind tunnel, and you can send air in different speeds. And you can study the forces acting on it. From that, it is possible to calculate the value of CD and CL. CD is coefficient of drag, CL is coefficient of lift. And here, this upward, central nose, and downward nose, three different prototypes of same dimensions are tested in a wind tunnel, and the results are as follows. Results are shown here. For upturned nose, CD is 0.24. For central nose, CD is 0.223. Downturned nose, 0.224. There is no much difference in CD. It's almost the same, only a slight difference in that. But you take the lift. The coefficient of lift for an upturned nose is positive. Positive means upward, and it is 0.2. And central nose, CL is 0.02. And for downturned nose, CL is 0.1, minus 0.1. Make it a point, for upturned nose, there will be more air flowing through the bottom. The air flowing through the top will be less compared to the air flowing through the bottom. So there is a possibility for front end lift. Now, you take the front side of the car, the edges of the front side can be rounded or chamfered. Here it shows the variation in coefficient of drag with radius of the round or chamfering radius. As the chamfering radius increases, you can see the coefficient of drag is coming down. And it is slightly less for chamfered corners. This is chamfering of corners. Then bonnet slope. The bonnet slope, we know when air is striking a plate kept at a particular angle, there will be lift and drag force. And here, the coefficient of drag is calculated for different angles of bonnet slope. See, as a bonnet slope angle increases, the coefficient of drag is coming down. Like that, windscreen rack angle, that is the angle between the windscreen and normal. That is shown here, windscreen rack angle. And as the angle increases, the drag coefficient decreases. Like that, there are so many parameters using which you can control the CD and lift coefficient. Here at the top, instead of keeping it flat, a small curvature is given. Here, H refers to the height at the center. L is the length of the roof. By varying this height, the coefficient of drag can be reduced. Like that, on the side, body side panel, that also compared to a certain extent. There it shows X is the camber in that. Can you see that? And L is the distance between the wheel centers. By increasing X, it is possible to control the drag coefficient. So what I mean to say is, this is for a particular body tested under wind tunnel. But for different shapes, it may have different values. Now, rear side panel taper. See the taper. Here, X1, X2, X3, X4. Here also, the coefficient of drag decreases, but it is not following a particular pattern. Even then, we can find out, we can conduct an experiment and we can find out what is the possibility for reduction in drag coefficient by changing the rear side panel taper. This is underbody rear end upward taper. Beta. Here, diffuser angle, by changing that angle, you can vary the drag coefficient. Ultimately, our objective is to reduce the drag. Here we have discussed many ways of reducing the drag coefficient and also lift coefficient. Rear and tail extension. If the rear and tail are extended, then the flow will be more streamlined. When the flow is more streamlined, naturally the drag coefficient will come down. This shows how the tail extension in millimeters for a particular body, for a body tested, drag coefficient varies with tail extension. Now, how that lift can be reduced? We have seen how drag can be reduced. Like that, lift can also be controlled or reduced. Here, we use wings, spoilers. Wings and spoilers are used to reduce the coefficient of lift. We'll see how it works. Here we have seen aircraft wings. If the aircraft wings work in opposite direction, that is, if the longer side is the bottom side and the short side is the top, when air flows, what will happen? At the top, it moves shorter distance. At the bottom, it moves more distance. When it moves more distance, it has to move with high velocity. When it moves with a high velocity at the bottom, normally the pressure will be relatively less at the bottom. And at the top, the air particles move shorter distance. So the velocity will be less. So high pressure will be developed at the top. When the pressure is high at the top and low at the bottom, the body will be pushed downwards. Okay, downward push. So in cars, there is provision. Mostly in racing cars, there will be wings. The wings are used to create downward push. Wings are used to create downward push. And there are air dam, and spoilers also. Spoiler is a barrier to airflow. Normally, the spoilers will be fixed above the trunk. What happens is when air flows above the vehicle, at the top of the vehicle, and when it approaches the part above the trunk, there will be a barrier to airflow. When there is a barrier to the airflow, what will happen? Pressure will be created there. When pressure is created, the pressure will develop and pressure will increase there. When the pressure increases, it will push the car downwards. So we can prevent the car from lifting up. Spoilers are used to create high pressure at the top of the car, above the trunk. You see, airflow is coming. When it reaches the spoiler, the pressure develops, and there will be a push downwards due to the high pressure developed in the trunk. Then air dam, I'll show you if it is clear. If a spoiler is provided in the front of the car, it is known as air dam. Air dam directs the flow in different directions. Air dam directs the flow in different directions. So the quantity of air flowing through the bottom will be reduced. When the quantity of air flowing through the bottom is reduced, naturally there will be less pressure. When less pressure is created and at the top, if there is high pressure, the car will be pushed downwards and there will be very good contact between tires and roads. Yes, see, air dam is provided in the front. Spoilers you can provide at the bottom, sorry, at the rear end, and there is low pressure because this air dam directs air sideways also. So the quantity of air entering the bottom of the car will be less, so low pressure will be created there. At the top, more quantity of air flowing over the top because it is the purpose of the air dam is to direct air in different directions. So it will reduce the flow of air through the bottom and it will increase the flow of air through the top. So at the top, high pressure, slow moving air will be there that will be pressing the car against the ground. So always there will be a push downwards. Then scoops, you would have noticed in cars, the front side. The purpose of scoop is something different. Here, this is scoops at the center. There is an opening, and what happens is when air is approaching the front side, air will be as air will be getting into the scoops. And what happens there? We'll see. When air enters through the narrow opening, and when it passes through the scoop, it will be compressed. Yes, there is a change of direction also. Air compresses in the airbox as it slows. And this compressed air will be supplied to the engine. When it is compressed, the density of air increases. So volume of air getting into the cylinder will be more. Now F1 cars, Formula 1 cars, and most of you would have seen Formula 1 cars in videos. Here, Formula 1 cars are mostly single seat cars, open cockpit, open wheels. Then wings are there at front and rear. What is the purpose of wing? To create downward force. Yes, this car will be moving approximately around 375 kilometers per hour. This is a racing car. When it moves at a speed of 375 kilometers per hour, if there is a lift created and if there is no contact between tire and the road, the driver may lose the control. In order to avoid that, wings are provided at front and rear end. And the position of the engine is always behind the driver. There is cockpit is very sparse environment. Driver has limited movement, and designers are forever trying to lower the center of gravity of the car. The reason is if the center of gravity of the vehicle is brought to the bottom, if it is lowered further and further, the advantage you have is the stability of the car. And all of us know whether in a body, if the center of gravity is lowered, there will be more stability. And F1 car, there are a lot of companies, Lotus, Williams, Mercedes, Red Bull. Like that, there are many companies producing F1 cars. And here, the point is how the coefficient of lift is controlled in F1 cars. Now, I have already mentioned about wind tunnel. Wind tunnel is an experimental setup to study the aerodynamic forces acting in a prototype. If you have a vehicle, you can make a prototype of it. You can keep the prototype inside wind tunnel, and you can allow the air to flow over the body prototype at different speeds, and you can study different forces, and from the forces you can calculate coefficient of discharge and there are this wind tunnel is a trial and error method, but there are so many softwares available. These softwares can be CATIA, hypermesh, Fluent, CFD software. There are so many softwares available. Using these softwares, we can study aerodynamic forces. We have to create a model and we have to test the model under different conditions. And we are coming to the conclusion. Here, all of us know that shape of cars influence drag coefficients and lift coefficients to a greater extent. And when someone select a car, he may consider many factors, and most important factors are fuel efficiency and stability of the cars. And this fuel efficiency and stability of the car in high speeds depends on drag coefficient and lift coefficients. And appearance of the car is also important, and noise level is also important. That also depends on the shape of the car. So we have to take care of these factors during the design of the car. I think you have enjoyed this session. Now the topic is open for discussion.
Now the session is open for discussion. Participants can ask any doubts. If you have any doubts, you can clear. Okay. So that was a wonderful and informative session by Professor Shivma sir, who has huge experience across various government engineering colleges across Kerala, and we are very glad to say that he's now he's now the head of the department, mechanical department at ACE College of Engineering. And hope this session was benefited by all the participants of this webinar. A feedback form is shared in chat box. Kindly fill this feedback form for the e-certificate. I thank Professor Shivma sir for spending his valuable time amidst his busy schedule for this online session. Thank you, sir.
Richu, 1 minute. Easily, എത്ര % ആൾക്കാരാണ് ഡിപ്ലോമ ഹോൾഡേഴ്സ്? നമ്മുടെ ഡിപ്ലോമ സ്റ്റുഡൻസ് എത്ര പേരുണ്ട്? ജസ്റ്റ് അറിയാൻ വേണ്ടി, പാർട്ടിസിപ്പൻസിനെ കുറിച്ച് അറിയാൻ വേണ്ടി മാത്രം. പാർട്ടിസിപ്പൻസിന് ഇന്ററാക്ട് ചെയ്യാം. ഇതെല്ലാവർക്കും ആൻസർ ചെയ്യാൻ പറ്റുന്നുള്ളതാണല്ലോ. ഡിപ്ലോമോ സ്റ്റുഡൻസ് ആര്, ഡിപ്ലോമോ കംപ്ലീറ്റ് ചെയ്ത എഞ്ചിനീയേഴ്സ് ആരെങ്കിലും ഉണ്ടോ?
ജയശങ്കർ PS, അജിത് രജി, അരവിന്ദ് RP ഹാൻഡ് റൈസ് ചെയ്തായിരുന്നു സർ. കുറച്ചുപേര് ഹാൻഡ് റൈസ് ചെയ്തായിരുന്നു.
എനിക്ക് ജസ്റ്റ് അവരുമായിട്ടൊന്ന് ഇന്ററാക്ട് ചെയ്യണമെന്നുണ്ട്, വേറെ ഒന്നും കൊണ്ടല്ല. ഞാൻ ട്രിവാൻഡ്രം എഞ്ചിനീയറിംഗ് കോളേജിൽ ഡിപ്ലോമോ സ്റ്റുഡൻസിന് കുറെ ക്ലാസ് എടുത്തിട്ടുള്ള ആളാണ്. ഞാൻ അവിടെ കോളേജ് ഓഫ് എഞ്ചിനീയറിംഗിൽ ഒരു പാർട്ട് ടൈം ഡിപ്ലോമോ പ്രോഗ്രാം ഉണ്ട്. ഡിപ്ലോമോ കംപ്ലീറ്റ് ചെയ്തവർക്ക് എഞ്ചിനീയറിംഗിന് ജോയിൻ ചെയ്യാം. അതിന് ഒരു ജോയിൻ ചെയ്യാൻ കുറെ ക്രൈറ്റീരിയ ഉണ്ട്. ഒന്ന്, ഒരു കണ്ടീഷൻ എന്ന് പറയുന്നത് എക്സ്പീരിയൻസ് ആണ്. മിനിമം 2 years എക്സ്പീരിയൻസ് വേണമെന്നേ ഉള്ളൂ. അപ്പം ഇതില് ഡിപ്ലോമോ കംപ്ലീറ്റ് ചെയ്തതിൽ 2 years എക്സ്പീരിയൻസ് ഉള്ള ആരെങ്കിലും ഉണ്ടെന്നുണ്ടെങ്കിൽ ട്രിവാൻഡ്രം എഞ്ചിനീയറിംഗ് കോളേജിൽ പാർട്ട് ടൈം കോഴ്സിന്, അതായത് എഞ്ചിനീയറിംഗ് ഡിഗ്രിക്ക് അപ്ലൈ ചെയ്യാം. ഇനി അതല്ലാതെ എനിക്ക് പറയാനുള്ളത്, ഞാൻ പാർട്ട് ടൈം ഡിപ്ലോമ ഹോൾഡേഴ്സ് കുറെ പഠിപ്പിച്ചിട്ടുള്ള, പൊതുവെ അവര് ആ സബ്ജക്റ്റിൽ കാണിക്കുന്ന ഇൻട്രസ്റ്റ് ശരിക്കും നമുക്ക് റെഗുലർ സ്റ്റുഡൻസിന്റെ അടുത്ത് കാണാൻ പറ്റുന്നില്ല എന്നുള്ളതാണ്. ഇതെന്ന് പറഞ്ഞാൽ അവർ സബ്ജക്റ്റിനെ കുറിച്ച് കുറച്ച് പഠിച്ചിട്ടാണ് വരുന്നത്. അപ്പം ഇത് ഡിപ്ലോമ സ്റ്റുഡൻസിന് എനിക്ക് ഒറ്റ ഒരു അഡ്വൈസേ ഉള്ളൂ. നിങ്ങൾ എല്ലാവരും, ഇപ്പോ നിങ്ങൾക്ക് പല ഓപ്പണിംഗ് ഉണ്ട്. നിങ്ങൾക്ക് പാർട്ട് ടൈം കോഴ്സ് മാത്രമല്ല, ഇപ്പൊ ലാറ്ററൽ എൻട്രി ഉണ്ട്, എഞ്ചിനീയറിംഗിന് ജോയിൻ ചെയ്യാം. ഈ നല്ല ഗവൺമെന്റ് കോളേജിൽ തന്നെ നിങ്ങൾക്ക് എഞ്ചിനീയറിംഗിന് ജോയിൻ ചെയ്യാൻ പറ്റും. യെസ്, ലാറ്ററൽ എൻട്രി ഒരു എക്സാം കണ്ടക്ട് ചെയ്യുന്നുണ്ടല്ലോ, ആ എക്സാം നിങ്ങൾക്ക് നല്ല രീതിക്ക് പെർഫോം ചെയ്യാൻ പറ്റുന്നുണ്ടെങ്കിൽ നിങ്ങൾക്ക് വളരെ ഈസി ആയിട്ട് എഞ്ചിനീയറിംഗിന് ജോയിൻ ചെയ്യാം. ഇവിടെ ലാറ്ററൽ എൻട്രി സീറ്റ് ഒന്നും അങ്ങനെ വലുതായിട്ട് ഫില്ലാകാറില്ല എഞ്ചിനീയറിംഗ് കോളേജിലും. അതുകൊണ്ട് എൻ്റെ ഒരു സിൻസിയർ അഡ്വൈസ്, നിങ്ങൾ എല്ലാവരും ഇത് ആരൊക്കെ ഉണ്ടോ അവര് ഇപ്പൊ എന്തായാലും നമുക്ക് ക്വാളിറ്റി ഇമ്പ്രൂവ് ചെയ്തേ പറ്റൂ. നമുക്ക് എപ്പോഴും നമ്മളെ മനസ്സിൽ ഒരു കരിയർ ഡെവലപ്മെന്റ് വേണം. ആ കരിയർ ഡെവലപ്മെന്റിനുള്ള ഇതില് ഇവിടെ ഉള്ള ഞാൻ ഇന്ന് അഡ്രസ് ചെയ്ത സ്റ്റുഡൻസ് എല്ലാവരും എങ്ങനെങ്കിലും ഒരു എഞ്ചിനീയറിംഗ് ഡിഗ്രി കോഴ്സിന് ജോയിൻ ചെയ്യണം. ആ എഞ്ചിനീയറിംഗ് ഡിഗ്രി കോഴ്സിന് ജോയിൻ ചെയ്യാൻ എനിക്ക് എന്റെ അഡ്വൈസ് എന്തെന്ന് പറഞ്ഞാൽ, ഇപ്പോ ലാറ്ററൽ എൻട്രി എൻട്രൻസ് ഉണ്ടല്ലോ, ലാറ്ററൽ എൻട്രി എൻട്രൻസിന് ഇപ്പം ഞങ്ങളുടെ കോളേജിൽ നിന്ന് ഒരു ചെറിയ കോച്ചിങ് കൊടുക്കുന്നുണ്ട്. ആ കോച്ചിങ് നിങ്ങൾ അറ്റൻഡ് ചെയ്യാനുണ്ടെങ്കിൽ നിങ്ങൾക്ക് ലാറ്ററൽ എൻട്രിയില് അഡ്മിഷൻ കിട്ടാനുള്ള ചാൻസസ് ഉണ്ട്. നല്ല കോളേജിൽ തന്നെ കിട്ടും. നിങ്ങൾ വിചാരിക്കുന്ന ഇപ്പൊ ഞാൻ വേറെ ഒന്നുമല്ല ഉദ്ദേശിച്ച് പറയുന്നത്, ഞാൻ പറയുന്നത് ഗവൺമെന്റ് കോളേജില്, നല്ല കോളേജില് ഫീ കുറച്ച് തന്നെ നിങ്ങൾക്ക് എഞ്ചിനീയറിംഗിന് അഡ്മിഷൻ കിട്ടാനുള്ള ചാൻസ് ഉണ്ട്. അതുകൊണ്ട് എല്ലാവരും, എന്റെ സിൻസിയർ അഡ്വൈസ്, നിങ്ങൾ എല്ലാവരും ലാറ്ററൽ എൻട്രി കോഴ്സിന് ലാറ്ററൽ എൻട്രി എക്സാം അപ്പിയർ ചെയ്യണം. ഇനി അതിന്റെ പ്രിപ്പറേഷൻ ആയിട്ട് ഇൻട്രസ്റ്റഡ് ആണെന്നുണ്ടെങ്കിൽ ഞങ്ങളുടെ കോളേജിൽ നിന്ന് ഓഫർ ചെയ്യുന്ന ആ ലാറ്ററൽ എൻട്രി എൻട്രൻസ് കോച്ചിങ്ങിന് ജോയിൻ ചെയ്യുക. അതിന് ഡീറ്റെയിൽസ് എന്തെങ്കിലും വേണമെന്നുണ്ടെങ്കിൽ ഇപ്പൊ ഇതിൽ കോർഡിനേറ്റ് ചെയ്ത നന്ദു സാറിന്റെ അടുത്ത് ചോദിച്ചാൽ മതി. നന്ദു സാർ അതിന്റെ ഡീറ്റെയിൽസ് ഒക്കെ അയച്ചു തരും. Anyhow, thank you very much, and I wish all of you a better future.